4,500 meters high. The higher you go, the thinner and lighter the atmosphere becomes. Breathing can become extremely difficult. Mountain climbers sometimes carry special oxygen-supplying equipment when they climb very high mountains. Since we're beneath all this atmosphere, a lot of weight is bearing down on us. That weight puts about 1 kilogram of pressure on every square centimeter of our bodies. We don't feel it because the pressure is equal all around our bodies, and we've adapted to it. We're used to it. It's a really good question, though, Terry. Thanks for calling. We'd like to hear from you again.
The air also carries tiny particles of dust and other solids called aerosols. Usually they're invisible except when they're crowded together in huge quantities. Aerosols include lots of things. Car exhaust and other pollution, salt from the ocean, volcanic dust, and smoke from forest and brush fires.
One more thing. In the stratosphere, ozone is added to the mix. There's not much of it, but what there is does a big job. Ozone protects living things from the sun's harmful ultraviolet radiation. Only 1/1,000,000th of the atmosphere is ozone, a sort of bluish gas. But ozone absorbs ultraviolet radiation more efficiently than any other substance in the atmosphere, keeping most of that radiation from reaching the Earth. If it did, forget it. The planet probably couldn't be lived on. A sunburn would be only the beginning.
And while ozone is beneficial in the stratosphere, it is a pollutant in the lower atmosphere. It can burn your eyes and lungs and harm plants.
This is for Brian.
We're here. What's your question?
What's this greenhouse effect stuff we keep hearing about?
Normally, sunlight passes through the atmosphere and heats the Earth's surface, which radiates heat back into space. But we're changing this natural cycle. We're cutting down huge forests that absorb carbon dioxide, and using enormous amounts of fossil fuels, which produce even more carbon dioxide, and other gases too. These gases are building up in the atmosphere, and like the panels of a greenhouse, trap much of the heat that would otherwise escape back into space. This global warming may radically alter the Earth's climate.
So, ozone in the stratosphere is good, but as a pollutant, it's bad. And the greenhouse effect keeps us warm, but too much of that is a bad thing, too.
Yeah, that's right.
Boy, it's time gone by fast. We're just about out of here. But before we split, there's something we'd like you to think about. How you can help take care of the atmosphere. For years, people figured that the wind and rain would just keep on cleaning the atmosphere no matter what. Well, wind and rain aren't enough. There are billions of people in the world, and what they do at home, in their cars, and at work is putting so many pollutants into the air. It's impossible for the atmosphere to cycle them all out. The governments of many countries have taken steps to cut down on the amount of pollutants people can put into the atmosphere. But it's up to each of us, too. We can do things every day to help keep the atmosphere clean. So you guys think about what you can do. Fossil fuels are burned every time we forget to turn out the lights or stand in front of a refrigerator. And we should remember to walk, ride a bike, or take a bus instead of driving whenever possible.
And so it is. For Saskia Young, this is Brian Bosak. We've been coming to you from our atmosphere. Next week, our show will focus on the wild world of insects. See you there.
So hot, it's cool, energy, 88.7 That was a great show as usual, guys. Next up, we have sports with Joe Costello, but first, let's hop up to the sky deck and Dave Carlson for the latest on traffic. Six, 5, 4, 3, 2, 1. Main engines burning. Liftoff of Atlas Centaur 73. Have a smooth flight of the vehicle so far.
A satellite rockets into space. From over 35,000 kilometers away, it transmits pictures of the Earth to a control center near Washington, D.C. The images alert scientists to changes in one of the most powerful and dynamic forces on the planet, the weather. The United States has the widest variety of weather of any nation on Earth. Some 1,000 tornadoes rip across its surface each year.
Step outside just a minute. Look, there's 2 more over here.
Thanks, over is.
And apparently these cars were in the garage.
Hurricanes batter its coasts.
But we've got some surviving to do.
Blizzards bury cities in deep blankets of ice and snow. From freezing cold to broiling heat, the U.S. is the weather capital of the world. Since everyone is affected by the weather, people are curious about what kind of weather to expect. The fact is, the weather is constantly changing. Not only does it vary from place to place, but a single location may see dramatic weather shifts during the same day. If the weather is constantly changing, how can you possibly predict it? How can you tell if tomorrow will be sunny or cloudy, or if dangerous weather is approaching? All over North America, students are learning to tell the weather. Outside Green Acres School in Fairfax, Virginia, students are installing a weather station of their own design and construction. Using basic instruments, including a wind direction indicator, thermometer, and rain gauge, they'll make observations about weather phenomena.
It's hot in here, but it's cold, yeah. Much hotter in here. Yeah, much hotter.
Observation is key to the science of weather, which is called meteorology. Meteorologists are the scientists we're probably most familiar with. We see them every day on television.
Our temperature's below average. Right now, we're actually a little bit below average, but look at the temperature change.
Meteorologists Bob Ryan and Andy Humphrey are part of a news team at Channel 4 in Washington, D.C. It's their job to forecast or predict the weather. How do they go about it? Meteorology has its roots in a long tradition of sky watching by farmers, explorers, and seafarers. They looked up to predict the weather. Now we have a totally different perspective. Weather occurs in the atmosphere, a layer of gases that surrounds the Earth like an ocean of air. Scientists divide the atmosphere into several layers.
Most weather occurs in the two layers closest to the Earth, the troposphere and the stratosphere. This is a very thin layer, almost as thin as the apple skin is to the entire apple.
This thin envelope of gases makes life on Earth possible. Energy from the sun warms the atmosphere, creating currents in the gaseous ocean. These currents move from the equator to the poles in a continuing cycle of moving air. Winds push masses of warm and cold air away from where they form. The air masses bump into each other, creating shoving matches that can escalate into atmospheric warfare.
Storms, in a way, are engines, if you will, in the atmosphere that move the heat from the south to the north.
The places where air masses clash are called fronts. Thunderstorms and other foul weather often occur along these lines. A cold front is created when a mass of cold air wedges under warmer, lighter air, forcing it out of the way. Cold fronts can produce dramatic changes in the weather. With heavy clouds and violent storms, you may notice the changes created by a cold front right away. After a cold front passes, the weather is generally nice and cooler. Brisk winds blow for a short while and give way to clear blue skies and dry, crisp air. This nice weather is called a high-pressure system. Warm fronts occur when a warm air mass slopes over a cold air mass, pushing it along. Weather changes created by a warm front may be far less dramatic than those caused by a cold front. Warm fronts take a lot longer to pass, sometimes days. After a warm front, it's often hotter and muggier with hazy or cloudy skies. Showers and thunderstorms may occur. The density of the air mass, as well as its temperature, affects the weather.
Air pressure is a term that is used frequently by meteorologists when making a daily forecast. Air pressure means the weight of the atmosphere above a certain spot on the Earth.
How do we measure the weight of air? What instrument would we use? One of the most basic tools of meteorology is the barometer. This barometer is basically a flexible membrane with an indicator attached. High pressure will force the membrane down into the can and move the indicator up. Once it's given an accurate scale, it will work very much like a professional barometer. Basic weather data, such as temperature, barometric pressure, and wind speed, have been used for years in formulating weather forecasts, and they still play a role in our ability to tell the weather.
Weather forecasting has made dramatic improvements during the last 20 years. This is because of three major items. One, weather satellites orbiting above the Earth. Two, weather radars which look inside the thunderstorms. And three, powerful computers. This is the new mix.
the National Meteorological Center in Camp Springs, Maryland. Most of the weather reports in the United States start here.
It's that front, and the Great Lakes down there.
Data